All right. So today we're going to talk about systems of inequalities, word problems. So just like we graph systems of inequalities on a coordinate plane and get the shaded regions, we do the same with word problems, only they're going to be in the first quadrant only because usually you can't have negative money or negative dogs or negative flour tortillas, whatever the problem's about. So technically you can have negative money because you can go into debt, but that's a whole different level of math. So we're not going to do that. So today what we're going to do is we're going to write a system of linear inequalities, just like you did writing a system of linear equations. Then we're going to graph them, just like we've been doing. Then we're going to look at our final graph and come up with two possible solutions that work. And because it's a shaded region, there's going to be lots of solutions. So if you're unsure if yours works, ask. Okay, so check the answer key and then ask. All right, cool. So let's look at the first situation. Suppose you buy flour and corn tortilla or cornmeal in bulk to make flour tortillas and corn tortillas. Flour costs $1.50 a pound and cornmeal costs $2.50 a pound. You want to spend less than $25, but you need at least 6 pounds altogether. So step one, define your variables. Okay, so oops, I did not open this in Notability. Sorry about that. So because flour came first, I'm actually going to call that X. And because cornmeal came second, I'm going to call that Y. Okay, so here we go. We're on the right page. So I'm going to say X is flour, cornmeal is Y. I'm just going to say corn. Okay, it doesn't matter. Whichever one you choose is fine, but it matters when you graph. So down here on my graph, I'm going to put a little arrow because there's not enough room. I'm going to put flour. And then over here, I'm going to put corn because we said flour was X, corn was Y. Okay. Now I'm going to write and graph a system of linear inequalities. So they tell me that flour costs $1.50 a pound. So I'm going to write 1.5X. Cornmeal is $2.50 a pound. So plus 2.5Y. And I want to spend less than $25. So I'm going to use the less than symbol and write 25. Okay. This is an inequality about money. That was this equation. Okay. What is the other inequality going to be about? Well, the only other thing they tell us is pounds. So this equation is going to be about pounds. So the pounds of flour plus the pounds of cornmeal have to be greater than at least 6. All right, there's my two inequalities. So now I'm going to put them into slope-intercept form and I'm going to graph. Now I understand this graph is small and it's going to be hard to figure out slope, but just do the best you can. We're looking for kind of the process and then you'll be able to pick some good answers for part 2. Okay, so I'm going to put this second equation into slope-intercept form by just subtracting x. Y is greater than negative x plus 6. Okay. I'm going to go ahead and just graph that right now. My y-intercept is 6. Oh, you know what? I'm not going to graph yet because I don't know how big my scale needs to be on either axis. So I'm going to put the other equation into slope-intercept form and then we can decide. Okay, so I'm going to subtract 1.5x from this equation. I'm just going to write it right here. It's because there's not a lot of room. I apologize for that. And I get 2.5y is less than negative 1. I forgot my x there. 1.5x plus 25. So remember, when you put it in slope-intercept form, the x term has to come first. All right, now I got to get rid of that 2.5. So I'm going to divide by 2.5, divide by 2.5, divide by 2.5. Okay, it's totally fine if you want to use a calculator. I get y is less than, well, a negative divided by a negative is a positive, and 1.5 divided by 2.5 is 0.6. Okay, so here's where it gets tricky. I get 0.6. It's really hard to do a 0.6 slope. So what I'm going to do is 0.6 is the same as 6/10, right? Because 0.6 is 6/10. And then 6/10 is a fraction that reduces. You can divide by 2. So I get 3/5. So because I want to use a slope that's a fraction, I'm going to do 3/5x. And then 25 divided by 2.5 is 10. Okay. So if that part didn't make sense, rewatch it, okay? You don't want a slope that's a decimal in these if possible. All right, so here's the two inequalities that I'm gonna graph. All right, so my y-intercepts are 6 and 10, which tell me that I could probably count by 1 on the y-axis. Okay, so here's how I do it. I do 1, 2, 3, 4, and then I put a 5 like that. 1, 2, 3, 4, and then I'd put a 10. Okay, that's what I would do. All right, cool. So let's graph the first inequality. The y-intercept is 6. So I'm going to put a dot at 6. And it's a slope of negative x, which is negative 1 over 1. So I'm going to go, oh, and you know what? My flour tortillas, I'm going to count by ones as well. 1, 2, 3, 4. There's my 5. 1, 2, 3, 4. There's my 10. Okay. So from my y-intercept, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And you know what? I'm just going to keep going. Oh, look, it also lands on 6 because the y-intercept is also 6. Okay. Going back to the symbol, this is going to, that's not the symbol. This is going to be a dashed line. Okay. So trusty ruler, you got to use a ruler. So I'm going to draw a dashed line through those dots I just did. Notice I'm not going out of the graph because you can't have negative flour tortillas and you can't have negative corn tortillas. And my equation says greater than, so I'm gonna shade this way. Okay, I'm not gonna shade too much because I gotta like put another graph on there. Okay, now I'm gonna graph the other one. So the other one has a y-intercept of 10 and it has a slope of 3/5. Yes. Oh, you know what I forgot? It's a negative. Ooh, did you guys catch that before? This was a negative divided by a positive. So I've got to have a negative right there. Sorry about that. Okay, so this says I'm going to go down 3 over 5. So 1, 2, 3, 1, 2, 3, 4, 5. There's my next point. Down 3, 1, 2, 3 over 1, 2, 3, 4, 5. Okay, I'll do it one more time. 1, 2, 3, 1, 2, 3, 4, 5. Okay. Cool. This has a less than symbol, so it's going to be another dashed line. Okay, so using my ruler, I'm going to draw a dashed line. Again, I'm not going into the negatives. And this time it's less than. So I'm going to shade below the graph. It goes like that. Okay, do you see the part where it overlaps? Hopefully so. This is the overlap region in here. Okay, so shade it. Remember to put your S in there if you want. Oh, I guess you could probably use another color. Put your S in there. Okay, maybe do this on Notability because then you can use all the colors. That'd be awesome. Or do it on paper and then just look at what you shaded. Okay, the last thing, part 2, or part B says, write 2 possible solutions. Anything in this shaded region is a solution to the system. But nothing on the line because they're dashed. They're less than and they're greater than, but they're not equal to. So I'm going to pick 2 points. Okay. So I'm going to pick this point right here. I mean, you can pick anything. This point right here is putting an arrow 2, 7. Okay. But because this is a word problem, I'm going to say what 2, 7 means. So we said flour was X. So that means I need 2 pounds of flour. Because remember, it was in pounds. We said Y was corn. So then I'm going to say 7 pounds. It's actually cornmeal. Okay. Pick another point. All right. So maybe I'm going to pick a point way over here. And I'm going to call that's 11,1. So I'm going to say 11 pounds of flour. And I'm going to say 1 pound of cornmeal. Okay. There you go. Your answer for part B can be anything as long as it's in the shaded region. So your graph has to look just like the answer key in order to get the right ordered pairs. Okay, and again, you can't just write 2, 7 and 11, 1. All right, cool. We're going to do one more, okay? I'm not going to do the whole thing because I think you guys are fine with this. Just be careful about how you do your scale, okay? So when I did number 3, the numbers for number 3 are bigger. Like we have 30, 50, 3,000. So when I ended up doing number 3, my graph was, I counted by 5s. So I did it like this. Okay, so you might want to write that down as like a hint because the scale is different. In number 1, we counted by 1s. Here we're counting by 5s. And then I did the same thing over here. I did 10, 20, 30, like that. Okay, so that's helpful. Just take a look at what your y-intercepts are before you decide how to graph. Okay, the last one I just want to look at really quickly is number 6. Okay, number 6 is going to ask you some different questions. Okay, so you're going to write and graph a system of linear inequalities. Then you're going to answer questions like this. Okay, so you have your systems of inequalities. So let's write them really fast. You like to see how many baseball and soccer games you can attend this spring. Travel time for baseball games is 2 hours and travel time for soccer games is 1 hour. You would like to spend no more than 15 hours traveling. In total, you want to attend at least 8 games. So I'm going to say X is number of baseball games. I'm not going to write games though. Y is number of soccer. Okay, so hit pause, take a second to see if you can come up with the 2 inequalities that you need to then graph. Okay, so hit pause, check it out, come right back. All right, hopefully you actually hit pause and tried it, okay? So my first equation is gonna be about hours. I said 2 hours per baseball game plus 1 hour per soccer game, and you don't need the Y, I just put it to be helpful, is no more than, so less than or equal to 15. So they're saying I'm willing to travel 15 hours, but I don't wanna travel any more than that. My second equation was about the number of games. So the number of baseball games plus the number of soccer games has to be at least greater than or equal to 8. Okay, you're going to graph that. Then they're going to ask you these tricky questions, okay? So suppose we decide on attending 4 baseball games. So that's X because we said baseball is X. What is the range of soccer games you can attend? So here's what I would do. I would take your X, this is 4, and I would plug it in to each equation. Okay, so 2 times 4 plus Y less than or equal to 15. So I have 8 plus Y less than or equal to 15, Y less than or equal to 15. Or just kidding, Y is less than or equal to 7. Okay. So I can only go to 7 or less games in that equation. Now I've got to plug my X into the other equation, and I get 4 plus Y greater than or equal to 8. Y is greater than or equal to 4. So in order to make the second inequality true, I have to go to 4 or more games. But in order to make the first inequality true, I have to go to 7 or less games. So I can only go between 4 and 7. So if you think back to the last unit where we talked about domain and range, they're telling me that I can only go between here and here. So like maybe this was my function. Okay, think back to functions, right? So this is going to be written as a compound inequality. I'm going to say soccer games is Y, okay? So Y has to be less than or equal to 7 and greater than or equal to 4. And that is the domain right here of this inequality. And that's the number of games I can attend, soccer games. Okay, if this gets tricky when you're doing it, let me know because C and D are really similar, okay? You're gonna plug them into your equations and then decide what you have left and then write it as a compound inequality. Well, at least for part C. Okay, please get help on this. Inequalities are great to solve, but it's the application of them that makes sense. Okay, and that's how you figure out all your combinations and your options. All right, cool. You are almost to the end of the unit. You're doing a great job. Use a ruler. Remember dotted line, dashed line. Please get help if you need it. You're doing a great job. Okay, bye.